Warahmatullah, Doctor. My name is Abdulaziz Mahmoud Hussein of ID 1088778. And today I'm going to be explaining my computer vision project and my specific contribution to the project. The project was threat level identification of dangerous items in airport security. Initially, what we did was we got our data, we analyzed it, then we applied data augmentation such as resizing and editing the brightness uh, of all the images. And the reason why we did this is to kind of have a level playing field with all the images when we're doing the classified training. Once we did that, we split our data into training, testing, and validation data splits. After that, we did computer vision techniques to extract features, and those features we train our model on. And then we got our annotations of the images, and we masked them to the images, and we did the YOLO training, and then finally we did our integrated system. So I'm going to share my screen now, and I'm going to explain my specific parts of the project. So the first part I did of the project was the feature extraction part. Initially, it's not here. It is- yes, here. So initially, what I did was I collected the data. I switched it to a grayscale. The reason why we did grayscale so that we focus on the image features first. Then we did hog feature extraction. We did hog just to identify the objects, identify the outlines, and get those specific objects. I can actually show you a picture of an image after we did the hog feature extraction. So here's a gun image after hog. We can see where the part with the gun shows a bit more than the rest. After that, what I did was the LPP feature extraction, which helps us find the texture of the objects. Next, we did candy edge feature extraction. What candy does is it makes the edges stronger so that we can identify the outlines of the objects much better. After we did that, we combined all the features in a matrix format where the number of rows was the image itself, and each column was a specific feature. So we ended up having 8,123 features. After that, we exported it and we used it in our step 4 model trainings. If I go back to our step 4 code, which we did in Collab because of the heavy training we had. So step 4, 5, and 6 were done in Collab because there was heavy training. We didn't want to do it locally. So in step 4, we got our features from step 3, and what we did was we trained 3 different models. So I'm going to show you the models here in our output files. So we have 3 different models. We trained X-ray trees, great results. It gave us solid accuracy results. It gave us a lot of decent results, but it wasn't our best one. Uh, After we did X-ray trees, we also trained on the SGT SVM. I would say this gave us the worst results out of the lot. Hence, we didn't select it. The model which we indeed selected was the linear SVC. This is the model which gave us the best accuracy, total accuracy, which was 0.64. The accuracy result was not high, and that was because of the feature extraction we did out in step 3. And as you can see here, we trained our model on these specific features. So just to quick recap on this part, we trained three different models, all on ePort of 60. We trained X-ray trees, linear SVC, and SGT SVM, and we chose at the end linear SVC because it gave us the best results. And this was the model where we then use in our final step in our integrated system. Just to recap my specific contribution to the project, I am the one who did the feature extraction using Hog Canyon and LBP. Put them in a folder in which we trained our models in. The models I trained were linear SVC, X-ray trees, and SGD. And after we did training on the features, we found that the best model was the linear SVC, in which we moved forward to our final integrated system. the most difficult part of this project, and the challenge we faced was the coding part of the model classifications, the feature extraction using computer vision techniques. We're usually more experienced on doing these codes on MATLAB, so doing them in Python should have been easier, but then we just didn't know the shortcuts to kind of maneuver the project better. Um, we also had issues with the data set. It was a challenging data set, especially in the step 5 in which we did the YOLO training. We usually have the YOLO training boundary boxes that label text, but then here we had it as black image with the white pixels and indicating where the object is. And finally, we had the what do you call it? The another challenge we had was to integrate the whole system together and kind of getting into the final submission folder in which we submitted. That part, it was difficult for us because we're not really used to giving code and running it on another system without having any issues with it. We usually just run everything locally or by Google Colab. And how we overcame the challenges is obviously with AI tools really helped us a lot, but also in class activities such as the labs really helped us a lot. Um, this project taught us how to use YOLO models with annotations and mask. It also taught us how to extract features which we deem as important for our images. And it also gives a lot of insight in different YOLO technique, computer vision techniques, I mean. Alhamdulillah, it was a good project and we learned a lot from it. And hopefully we see you in other courses, doctor. Thank you so much.